given the following conditions, we're going to find the Cartesian equation. First thing to do here is if we just look at PS squared. Okay. Now, PS squared by Pythagoras is this distance squared plus this distance squared. Okay. So the red distance is x minus AE. If that was a point with coordinate x, then the red distance is x minus AE squared, and the y distance is equal to y squared. So the y distance is y, so this is PS squared is equal to that. PM squared, so PM squared is even more straightforward. It's this distance, A over E, minus x all squared. Okay. Now, we are given that the eccentricity is the ratio PS over PM. And therefore, we can say that implies that PS squared is equal to E squared PM squared. Taking the PM to the other side and squaring both sides. We can now substitute this property into here. And we can have a relationship exclusively in terms of x, y, a, and e. Okay, so we sub that in. We can say PS squared okay, so PS squared x minus AE squared plus y squared has to equal to E squared bracket A over E minus x all squared. The right hand side is as follows. If I square out the bracket, you can see that the E squared cancels out and you're left with, on the right hand side, A minus EX all squared. And on the left hand side, it's the same. Okay, so let me just expand the bracket on the left hand side. So it's x squared minus 2 AEX plus A squared E squared plus Y squared is equal to A squared minus 2 AEX plus E squared X squared. So here we can see that this cancels out. So I can bring the x squared to the other side. So I have x squared minus E squared X squared plus, that's fine, now I'm bringing it to the left hand side, plus y squared is equal to A squared minus A squared E squared. So if I factorize the x squared, I have 1 minus E squared plus y squared is equal to A squared bracket 1 minus e squared. Now, dividing both sides by a squared 1 minus e squared, have here x squared over a squared plus y squared over a squared bracket 1 minus e squared is equal to 1. So we know in an ellipse, in the case where x squared over a squared plus y squared over b squared equals to 1. Okay? Now this corresponds, now this would make an ellipse if this term satisfies the condition that it has to be positive. In other words, is that right? Are we happy? If it is between 0 and 1, and we can see that B corresponds to that expression, a squared bracket 1 minus e squared. So we can say now we have important results in our ellipse. B squared is equal to a squared bracket 1 minus e squared. I'd like you to memorize that result because it's an important property. Okay, I'll put a red box around it so you can remember it. Okay, so we've established that given this property, we can prove the following. X squared over a squared plus y squared over a squared bracket 1 minus e squared is equal to 1. And because of the symmetry, we have foci at the point AE, 0 and minus AE, 0, and directrices the line x equals a over e and x is equal to minus a over e. So those are important points I'd like you to note. Take a mental picture of that. Now the general form for hyperbola is x squared over a squared minus y squared over b squared is equal to 1. Now, what should I do to make this one minus? What could I do to, we have derived this property, okay, so what could I do to change that sign into a minus sign? E squared has to be equal. So let me just now times top and bottom by minus 1. So I'm going to say that as, so here, if I times top and bottom by minus 1, it doesn't change the property that we've taken so long to derive. Okay, so I'm not going to derive that again. But if I did times top and bottom by minus 1, x squared, okay, over a squared. Now, plus, if I times the top by minus 1, I get minus y squared. If I times the bottom by minus 1, I get a squared bracket up e squared minus 1 is equal to 1. Okay, and of course plus and a minus, if we're stuck, is a minus. So I can change that, and now that looks like a hyperbola to me, just by multiplying top and bottom by minus 1. And therefore, what condition can I say, given a hyperbola, how can I relate A, B, and E? What is the formula that now I can now come up with for hyperbola? I can now have my second property, which is that B squared has to equal to A squared bracket E squared minus 1, given that E is greater than 1.